I'm here to introduce Simon JeanPierre from Fermentis. Simon's the Technical Sales Support Manager for APAC, and in his role as regional, he supports the regional sales team with technical knowledge and help with research and development. Just a reminder for everybody as well, if you do want to ask questions, please do use the app. I'll be keeping an eye on it. So, welcome, Simon.
Thank you, Claire, and good afternoon, everyone. Welcome to this session about thiols. A very interesting topic nowadays for a lot of brewers. It's been a lot of research going on at research institutes, but also at Fermentis. We've been looking at yeast and hop interaction for a while. We started looking at cascade hop 5 years ago, as it was one of the most used hops, and then we wanted to prove the existence of yeast and hop interaction. That was actually a successful study. And then we looked also at trending styles like fruit IPAs, New England IPAs, and what kind of yeast was best suggested for the use in such heavily hopped beers. And the last study in the collection, if I may say, is about thiol release. So the release of free thiols from bond thiols, and looking at different yeast strains, lager and ale, and how they can, from their enzymatic activities, release more of the thiols from the hops that you are using in your beer. So another way to look at it, if you look at the title, free thiol release, so what we mean with that is the releasing of free thiols from bound thiols. But that's also a way, a sustainable way to have some more free aroma coming out of your hops from the same quantity. You can express much more by choosing the right yeast and the right fermentation conditions. So this is what I will be covering in this session. And the menu for today, a bit of introduction on the thiols, the material and methods that we have used in the study to look at those thiols released in hops, and to look at the results and discussion, and then finally some conclusions. So a bit of introduction on the thiols. Sorry, this slide is very busy, very chemical, but don't worry, it's going to be simplified on the rest of the slides. But what we want to show you here is that thiols are aromatic compound that you have in malt, but mostly also in hops. And depending on the size of the chain, depending on how long is the molecule, you have different perception of the thiol flavors. If you have a short chain, you may have like some garlic, cheesy, onion-like flavors, not so enjoyable in a nice hop-forward beer. But if you have longer chain of thiols, then you have very aromatic compounds with a lot of tropical aroma linked to them, such as passion, citrus, passion fruits, grapefruits, flower, blackcurrant, etc. So very, very enjoyable flavors. And to simplify a little bit how we will present the thiols on the rest of the presentation, you can see here the list of the thiols we have been studying in this study. And to make it more simple, so instead of talking about 3-sulfonyl hexanol, for example, for the first one that you see there, you can just we will summarize it with the short version 3-8-SH. And then what you can notice is that you always have thiols, pair of thiols. So you can always find them 3-SH under the alcohol form. You have the OL here at the end, so it's an alcohol form of thiols. But what you will also find in beer is esterified version of the thiol, so meaning that with the activity of the yeast, you can further convert the thiol into its acetate form through esterification, and then have another flavors as you can see here, you may have one aroma for the alcohol form, but then if you have esterification from the yeast, then you have another aroma expression and another threshold in the beer. And I don't know if you have an idea of what it is like, 55 nanogram per liter. That'd be roughly like 1 drop of the pure compound in a swimming pool, which is like huge. So those are the 6 thiols we have been studying. Why? Because they're the most aromatic in beers. They have low flavor threshold, so meaning a high impact in a beer. The objective of the study was to look at a few hops. So those were the hops that we studied, and we looked at the amount of bound thiols that we have in those hops. And you have always the bound thiols under cysteine form or glutathione form. On the next slide, you will understand a little bit better the chemical process involved, the enzymatic activity involved, but the main target was to look at the brewing process. Okay, we are using hops, they have thiols, we're using malt, they have thiols, but how and when those thiols are expressed in the beer, and how yeast and fermentation conditions can eventually impact that to improve this release of thiols. And if we look at what is happening from research on this yeast and hop interaction in the context of thiols, you can imagine thiols, the bound thiols, you can imagine them with here linked to, you have the aromatic molecule, the thiol, linked to a chain. And this chain can either be cysteine, here on the left-hand side, or can either be glutathione. Those are amino acids, here chain of amino acids, here one amino acids. But when they are bound together, when the cysteine or the glutathione is bound to a thiol, you don't perceive them in a beer. They are not aromatic. But with the action of the yeast, and of course as a yeast supplier I'm quite happy that the yeast is giving a good impact on that, but the yeast has the ability through some enzymatic activities, the yeast has the ability to release, to break down the chain here and release the thiols in the beer. So release a very aromatic compound in the beer. And we have 2 different scenarios. First one is cysteine adduct. You only need beta lyase to release the thiol from a cysteine adduct. And for the release of thiols from glutathione, you need not only beta lyase, but also gamma GT, and carboxypeptidase, because you have more chain here to break in order to release the thiol in the beer. So that's for the chemical part. This is another very busy slide about the yeast metabolism. You have seen yesterday from other yeast suppliers talking about all of these processes, but today we will not focus on the different aromatic compounds that are involved in those metabolic pathways. We will focus on the thiol. So what is happening when you have yeast and when you have some thiols, precursors in the beer? Those precursors are getting inside the yeast cell, and then thanks to the action of the enzymes that I just mentioned, so beta lyase and gamma GT carboxypeptidase, you have the release, the chain is cut, and you have the release of the thiol inside the yeast cell under the alcohol form first. And then this alcohol form of thiols can either go outside of the yeast cell, expressing the aroma that is linked to the compound, or what you can have is the esterification, as I mentioned before. So the alcohol form is through esterification by the yeast, further converted into an acetate form, which is usually more aromatic than the alcohol form, so very impactful on the flavor. And then the same way as the alcohol form, it would be perceived in the beer, it would be coming outside of the yeast cell and express the flavor in the beer. So we wanted to study this in more details, and we wanted to understand, okay, what kind of yeast, what are the yeasts that would be more favorable, more performant in releasing those thiols? Is it the same for every yeast? Do we see a difference for lager and ale? Do we see differences in the ale strains? And can we also change that with fermentation conditions? So this is what we wanted to answer in the study that we have done in Belgium. And here's the protocol that we have used. To make it more consistent, we have not used fresh hops because you have variations in between batches. We wanted to get rid of that, so we used synthetic precursors, aromatic precursors, so cysteine adducts and glutathione adducts that we added in a non-hopped wort. And then we went through fermentation, 7 days at 24 degrees Celsius, and then 3 days at 4 degrees Celsius by using different ale strains and different lager strains. So a lot of fermentation flask, a lot of trials, and a very long process of extraction at the end of the fermentation and maturation. We did an extraction process to be able to take the thiols that were produced, and then we measured them through gas chromatography. And the results were very interesting. So what we have done, we measured a concentration of thiols at the end of the fermentation, and we knew what we added from the start. So from the amount of precursor, we have been able to get a percentage of those precursor released into the beer into the form of thiols. And this is the results that I'm presenting to you here. On the left-hand side, you have the percentage of thiols released from the precursor. And here at the bottom, you always have the different yeast strains that we have been looking at. And you always have you have 3 different pairs of thiols, 3SP here, 3S4MP here, 3SH here. And each time you have the alcohol form and then the acetate form for each pair of the thiols. So how can you look at this? First, we can look at what are the yeast giving the highest percentage of release. And we see that the pattern between the 3 different pairs of thiols is pretty similar. So K97, SAF Ale K97 was always the one showing the highest percentage of release. But then, if you look at the ratio between the alcohol form of the thiols and the acetate form, this gives you an idea of the power of esterification of the yeast. So how much of the alcohol form of thiols can be esterified by the yeast, which is also important because the flavor threshold is even lower for some of those thiols. So for example, if you look at S33, USO5, SO4, they're showing high esterification rate, higher esterification rate than K97. And this is something we also observe here for the 3S4MP. And for the 3SH, there is much less esterification going on. So to conclude, what we can take from that is that we see similar pattern. K97 showing the highest rate of release of thiols under the alcohol form. Good esterification from S33, SO4, USO5, and a very similar pattern as I mentioned already. And so this was for the cysteine adducts, so from one group of precursor. And if we look at the glutathione adducts, so the one that are needing not only beta-laiase but also gamma-GT and carboxypeptidase, we see that, for example, for 3SP, not much thiols extracted here. What you can also note is that the percentage of release is around 10 times less for the glutathione adducts than it is for the cysteine adducts. There are more enzymes involved, so it's maybe more a longer process, more difficult for the yeast to release the thiols. But what we have seen from the hop analysis we have been doing as well is that generally you have more glutathione adducts in the hops. So it is still interesting to have such a percentage of release in those hops. So again, K97 showing a very high rate here for 3F4MP, and a similar pattern, K97 showing the highest percentage of extraction. And then not much esterification here. You see that the acetate form is very low, in very low amount. And here, a bit more esterification, USO5, very high esterification, SO4 as well, to release acetate form of those thiols. So again, K97 selected, confirmed as the highest release of thiols here. And then those results, I presented them already one time in Australia, and the next slide is something that I never presented, and those are the results for the lager strain. So if you're looking at any hop-forward lager, thiols release in lager beer, this is the slide to remember for your next beer. So you have here a comparison between K97 as the one from the ale strain showing the highest release. And then we have our 3 lager strain, S23, W3470, and S189. And very, very surprisingly, lager strains have very good efficiency in releasing thiols. If we compare with the best one from the ale range, you have a very nice extraction of thiols with the lager strains. S23 is showing the highest release of thiols under the alcohol form. We can see a lot of esterification with S189, and W3470 also showing very nice extraction of thiols. So making them potential candidates for hop-forward beers to have those thiols shining through depending on the hops that you're using. And this is about the yeast, but we also wanted to understand, as I mentioned at the beginning of this presentation, we wanted to understand what can you do on the fermentation conditions. Is there any influence depending on the fermentation conditions that you will use? So we have been looking at a measurement of thiols at different stage of the maturation process in order to understand if there was an influence of time or maturation on this. So you have listed here all the thiols that we measured. Here you have the days of maturation. So 0 day of maturation means end of fermentation. And what can you see there is that at the end of fermentation, we didn't measure thiols as of yet. We were able to measure some thiols after 3 days of maturation, meaning that something is happening, maybe a stress on the yeast, causing the release of the thiols from inside of the yeast cell, outside of the yeast cell. That is, that is maybe a possibility. And what we see again is that cysteine adducts, you have a higher percentage of release as we have seen before. And here, if we look at the glutathione adducts, we see a pretty similar pattern. So an increase, if you increase maturation time from 3 to 5 days, you have higher increase of thiols release under the alcohol form. And you have also an increase of the esterification, the acetate form of thiols released in the beer. So our suggestion would be for hop-forward beer, if you want to have good thiol release, we would suggest at least 3 days of maturation as a good compromise between acetate and alcohol form of thiols. Then we looked also at the gravity. Would it be influencing the amount of thiols that you can release? And what we see is that yes. So on the left-hand side, you have for the cysteine adduct, we see that at 12 plateau of original gravity, you have higher extraction of thiols. And then And then from 15 plateau, we see that you have an increase of the esterification rate. So here at the top, you have the alcohol form. Here at the bottom, you have the acetate form. So if you have higher gravity, then you have a higher tendency to have esterification. It's kind of promoting it. We see the same pattern here for the glutathione adducts, meaning that if you want more thiols under alcohol form, depending on the flavor you want, then maybe 12 plateau would be better. If you want to compromise between the two, then in this case, you can go for a 15 plateau. And to go a little bit further, even further than that, we wanted to understand by using different hops, because we know that different hops have different amount of bound thiols, different amount of free thiols, just from their genetics, from the varietal. So from those results, from the percentage of release, we did an experimental theoretical recipe to do an extrapolation of the results, and in a theoretical recipe to have an idea of how how the different yeasts would impact the release of thiols by using specific hops. The hops we have been looking at are Citra, Alerto Blanc, and Polaris. And as we can see on this slide, we have each hops have different amounts of free thiols and bound thiols. Some hops have a lot of free thiols already from their nature. Some hops have a much higher amount of bound thiols compared to free thiols. So yeast will have a different impact depending on the hops that you're using. And Citra, for instance, is showing high amount of free thiols here, 3-SHA, which have very low flavor threshold. And hops like Alerto Blanc or Polaris have less of those hop thiols. So how would it look like in a theoretical recipe? How much thiols could you expect by using Citra here, and by using either of those yeasts listed at the bottom? So here on the left-hand side, you have in other units the amount of thiols from free and bound thiols. So in other unit, one other unit means that it is perceivable in beer, because other unit is the concentration of the flavor divided by the flavor threshold. So anything above 1 is something that you would be able to perceive, we would be able to perceive as a human. So here, what you see is that in Citra, already just from the varietal of the hop, you have already a huge amount of thiols, such as, for instance, here, 3-SHA. You have a lot of thiols expressed. So yeast, here is the influence. This is the influence of the yeast. So by using yeast through the yeast metabolism, you have an idea of the impact of the yeast here, and you see that in other unit it's between 1.5 and 2.5 other units out of 20 something that you have already in the hop. So not a big impact here of the yeast for a hop like Citra, which has already a lot of free thiols. But if we look at other hops like Alerto Blanc, we see here that from free and bound thiols, the total amount you can have in our unit is around 5, between 4 and 5. And on the right-hand side, the impact of the yeast, so the thiols that you can only have from an extraction from the yeast, is between 1.5 and 2. So here, almost 50% of what you can perceive is thanks to the yeast and hop interaction, thanks to the release from the yeast. So with a hop like Alorto Blanc, the choice of your yeast, the choice of the yeast will be more impactful on the thiols that you perceive in the final beer. And then if we finally look at Polaris, on the left-hand side, you see here the total amount of thiols that you can expect from free and bound thiols. And it's like around between 2 and 3. And you actually see that all the thiols you are able to perceive in a experimental beer recipe with Polaris is thanks to the yeast and hop interaction. So if it was not for the yeast, if we were not able to have this extraction from the yeast, you would not perceive thiols from Polaris. So it makes it quite interesting. If you talk to the hop suppliers, if you look at the climate change, they are changing the variety that they are using. We're seeing new kind of hops on the market. And this kind of study is telling us that maybe you can release more potential from some hops that have very low amount of free thiols. But thanks to the yeast and hop interaction, you can expect even more from variety with low free thiols. You can actually use the right yeast, use the right condition to express even more for this kind of hops. So to conclude, these new results confirm that, yes, again, yeast and hop interaction is not a myth anymore. Certain yeast have higher capabilities in releasing thiols than others. From our range of ale yeast, we have seen that K97 was the best candidate to release thiols under the alcohol form. Then if you're looking for acetate form of thiols to have other flavor compound, other aromatic expression, then S33, SO4, USO5 were very good challengers from their higher ability to esterify and have acetate form of thiols. Then on the process itself, if you want to have the optimum release of thiols, we have seen that 3 days of fermentation or more was really necessary in order to release the thiols into the beer. In terms of original gravity, if you want to have a nice balance between alcohol thiols and acetate form of thiols, 15 plateau was seen to be a very good compromise. And this study has been done in Belgium thanks to the University of Louvain. And before leaving you, I would like to show you a few more slides on the new Fermentis campus that we will have. This new campus is in north of France, in Lille. And it will host my colleagues in Europe, my lucky colleagues in a very new office. It will host also visitors, you guys. If you're visiting Europe, feel free to reach out with your sales rep. We will get you in touch with our colleagues in Europe, and you'll be able to visit this new facility. What's in there? My favorite thing is that we have a brand new applied research center. So this kind of study, we will be able to do it also in-house. We have a Kaspar Schulz brew house with 50 fermenters. That's like the best toy you could ever dream of, right? I would love to have this in my garage, but it would not be big enough. So 50 fermenters. So basically, we can do like the same wort, do kettle sour, no kettle sour, divided into different fermenters with different yeast or same yeast, but different temperature, different conditions. It's just amazing everything, the amount of information, the amount of data, and the amount of knowledge that we'll be able to get from our product, from this applied research center. We have also open fermenters. We have a barrel aging room. We have a sensory lab where we run twice per week. We have a panel of experts that they are tasting the beers from our different research, so we can get more data on not only the analytical part, but also how yeast is shining through in terms of sensory in certain beer styles. And in terms of picture, yeah, this is how it looks like. So pretty fancy Kaspar Schulz fermenters. Yeah, it's really nice. So if you're visiting Europe, if you have a trip organized, just feel free to reach out. We would be very happy to welcome you. You have a tour with our brewers. You can sip some beers from the fermenters. Yeah, have a good time. And we actually have what we call the sharing days. So those are 3 days where we welcome our customers, brewers from all around the world. Everything is organized. If you're coming, we can send you an invitation, and you can come to those sharing days and taste beer, learn more about our products, meet the whole team, the R&D team, and also the team from the rest of the world, and yeah, share beers and have a great time. Anyway, I can answer any questions you have about thiols, and we can also drink some thiols together. Thank you.
Thank you very much for that. That was very interesting. We have got a couple of questions, so
Yep.
if you want to stick around. If any, were there any changes in the fermentation parameters between the ale and lager strains?
No, we have not used any different fermentation conditions. Even the temperature was kept the same. We didn't want to change too many variables. So that was no changes between ale and lager yeast.
And Matthew asks, with SO4, S33 and K97, would co-pitching show similar thiol release with a yeast such as USO5 or other lager strains?
Yeah, good one. So I'm sure the R&D thought about it, some co-pitching, but this was already a very expensive study. A lot of different conditions, a lot of different yeast, a lot of sampling points, and thiol analysis are quite expensive. As you have seen, it's a very long extraction process. So unfortunately, we have not been able to assess by ourselves if a co-pitching would have like the best of each yeast. But my personal opinion would be that yes, you could have, if you take a yeast with, if you take K97 with a high extraction of alcohol form and another yeast with good esterification, I would assume that you can combine the two and then have overall a higher amount of thiols released. That's a possibility, yeah. But I would like to check maybe at the campus.
And finally, and this is what I was wondering as well, so I'm glad someone asked this. Based on the volatility of free thiols, did you handle your liquid in any specific way during testing to keep thiol content in the beer? And on top of that, I'd like to know a little bit about shelf life and how the flavours go through the life of the beer, if that's okay.
Mm-hmm. Yeah, good question. So those trials were done in fermentation flask, but with a cotton on the top, so was not like closed to prevent any volatility of thiols. So the result that you're seeing here is like regular condition in your brewery. The fermenter is not totally closed, so you could expect a similar ratio of thiols released. And then on the shelf life of the thiols, we haven't been looking at how long in the beer those thiols were staying, but I would assume that in a packaged beer, those thiols will remain quite a long time. I don't recall seeing particular oxidation of the thiols in a beer, so you would normally have them for a while, yeah, in the beer, be able to enjoy those nice tropical notes.
Lovely, thank you. Has anybody got any questions? We've got a little bit of time. Reese.
G'day, I've done a number of hoppy beers with K97 for a few years. I'm just wondering if, with the experimentation that you've done, those initial beers, I presume all the hops you added were on hot side, rather than you didn't do any dry hopping with that?
No, yeah, it was It was just unhopped wort. So the only hop that were added were just directly the hop precursor for thiols. So there were no hop in there. What we wanted to study is not like the full yeast and hop interaction, because of course here I've been talking only about thiols, but yeast has also impact on terpenes, for instance, on beta-myrcenes and a lot of different other hop compounds. So here the focus was only on the thiol precursor, but you could expect, of course, much more with K97 in a yeast and in a very hop forward beer.
Cool.
Yeah.
Thank you. Any more questions? We've got a couple, so we'll go you and then Jake afterwards.
Just about the original fermentation temperature, have you looked at lower fermentation temperatures to then see if there's a different impact on that thiol release at the maturation stage?
So the reason why not is a little bit as the previous one of the previous question. When you plan an experiment, you have to make choices. But yes, I would totally assume that temperature would impact the enzymatic activity that you have involved in the release of thiols. So different temperatures would indeed influence the extraction of thiols. That's for sure. That's for sure. But something we need to explore further. Yeah.
Cool.
I think my question was almost identical. It was about the 4-degree maturation temperature and if there was any data at lower.
Yeah, unfortunately not. We had to choose only one as a start, but already giving a few nice results. And then, of course, you guys are more than welcome to try and let us know what you find, and then we can go further in that. I'd love to talk more about your findings and give us ideas, give us feedback, and then we can run some new trials at the Fermentis campus, and you guys come and try.
So on that then, do you have any tips, like what's the best way for brewers to retain like information on sensory and, to build up that picture? Is there any tips or how to record it, what to look for?
You mean as a brewer, how to retain information
on
about
the sensory aspects of it?
Yeah, well, I guess some of you guys are already running some sensory panel on your beer, maybe more on the quality standpoint, like is this beer on spec? Is it the same as previous batches? Do we have any off flavors? But training yourself, you can buy some flavor kits on thiols and some of the hop flavors. You can train yourself on some of the fermentative interesting flavors, positive flavors. And then with an inside program at the brewery, with regular training, some of the suppliers here, like also IBD and other institutes, are also doing sensory trainings. And I would definitely suggest every one of you to go into that if you want to have even more consistent control on what you're doing in your brewery, and then further improve in the flavor direction that you want to have in your beer. Yeah, being able to have this sensory would be fantastic, of course.
Cool. Is that it for questions? Oh, one more.
Do all thiols taste good?
No, and if you take them individually at a certain concentration, like slightly above threshold, it's good, of course. But the synergy of different thiols, or the intensity of a certain thiols between different people in this room, if you have like let's say a passion fruit, but like 5 other units of passion fruit or 20 units of passion fruit, we would perceive it very differently. Sometimes higher intensity would be better, sometimes lower intensity would be better. So it's really it's a very complex area. We don't have all the answers, and it's more like trial and error in order to better understand this kind of thing.
Cool. All right. Well, thank you. Let's give Simon a round of applause. That was really good.
Thank you.